Example 5, studying motion along a line. A particle is moving along the x-axis with position function, x of t equals this, for t greater than or equal to 0. Find the velocity and acceleration and describe the motion of the particle. Let's find the velocity. V of t is equal to 6t squared minus 28t plus 22. Let's factor this. Let's take not a 6, but a 2. 3t squared minus 14t plus 11. And then we can factor. We have 3t and t, and this will be minus 1 there and minus 11 there. So we'll get the negative 14. So we have t is equal to 11 thirds. T is equal to 1, and that's where the particle is stopped. Let's find where the particle is moving left and right. So we're going to do a number line. Here we have 1, and that's where the particle is stopped. Then 11 thirds is 3 and 2 thirds. We'll make a note of that. 11 thirds is 3 and 2 thirds. So here's 4. This could be 2, and we don't want 0. How about 1/2? And then over here is 0. So let's plug in a half. A half of 3 is 3 halves. 3 halves minus 11 is certainly going to be negative. And then 1/2 minus 1 is negative. So the particle is moving to the right here. And then when we plug 2 in, we get 6 minus 11. That's going to be negative. And then 2 minus 1 is positive. So the particle is now moving to the left. And then at 4, we're going to have positive and positive. So the particle is moving to the right. Now the acceleration, a of t, is equal to 12t minus 28. And we'll set that equal to 0. So we have 12t minus 28. So t is equal to 28 twelfths, which is 14/6, which is 7 thirds. So let's draw another number line representing speeding up and slowing down. We'll have 1 in here, so we got 1. The next number would be, let's see, we have 7 thirds versus 11 thirds, so we'll have 7 thirds, and then we'll have 11 thirds. So we know that on the left side of 7 thirds, we have, let's say 2. I have 2 and 2 thirds. How about 2? Well, if we plug 2 in, it's negative, so the acceleration to the left side of 7 thirds is negative, and on the right side, if we plug in something bigger than 7 thirds, how about that's 2 and 2? How about 3? 36 minus 28 is positive. Now we already figured out that to the left of 1, the velocity is positive, and then the velocity is negative, so negative here, but also negative on this side, because between 1 and 11 thirds, the velocity stays negative the entire time, and then afterwards the velocity is positive. So we know that we need to find out slowing down, slow down, and speed up. And so from 0 to 1, the acceleration is negative, but the velocity is positive, so that's slowing down. So 0 to 1, this is happening. And then from 1 to 7 thirds, we're speeding up. So then we have 1 to 7 thirds, and then slowing down from 7 thirds to 11 thirds. So 7 thirds to 11 thirds, and then speeding up again from 11 thirds to infinity. But we also have the left and the right. Left from 1 to 11 thirds, and right from 0 to 1, and then right again from 11 thirds to infinity. And let's do stopped. We didn't do stopped. At t equals 1 and 11 thirds. Second derivative test for local extrema. Example 7, using the second derivative test. Find the local extreme values of f of x equals, well, this function right here. So we're asked to find the extreme value. So f prime of x is equal to 3x squared minus 12. Then we can take a 3 out. We got x squared minus 4. And then we have 3 times x plus 2 x minus 2. So we have extrema at x equals plus or minus 2. And what we want to do here is we're going to use the second derivative test to find out if these are maximums or minimums. So let's take the second derivative of x, and that's equal to 6x. So 6x. Now when we evaluate this at 2, we get 12, which means we have a function that is concave up at 2. So if we have a local extrema there and it's concave up, we have a minimum. Find the local extreme values. Minimum of something at x equals 2. And then if we have f double prime of negative 2, that's 6 times negative 2, which is telling us that the function is concave down at negative 2, and so that must be a local maximum. So we have a maximum of blank at x equals negative 2. So we have a minimum of something at x equals 2. Let's plug 2 in. We have 8 minus 24 minus 5. Negative 16 minus 5, that's negative 21. And when we plug in negative 2, we have negative 8 plus 24 minus 5, that's 16 minus 5, looks like 11.